In this video, I'm going to go over how to draw the covalent Lewis dot structure for BF3, which is boron trifluoride. So again, the first thing you want to do is draw out your elements that are in the compound. So here we have 1B, which is boron. So since that's our only element that we have of that, I'm going to draw it at the center. And then the fluorine, we have 3 of those. So I'm going to go ahead and draw those 3 fluorines around the boron. Okay. And again, trying to make it as symmetrical as possible. You could always put this fluorine here. It doesn't really matter. I'm going to leave it here for now. And then next, we're going to draw out the valence electrons on each element. So boron, it is in group 13, so it is surrounded by 3 valence electrons. Also note that boron is one of the exceptions to the octet rule. It can only be surrounded by a max of 6 valence electrons. So that is one of our exceptions. Boron can only be surrounded by 6 valence electrons. Hydrogen can also only be surrounded by 2 valence electrons as well. So those are our 2 exceptions to the octet rule. Also, I'm going to put this electron, I'm going to leave this one here, but I'm going to move this guy over here just so that I have a single electron facing each fluorine, okay? And you know, this is the same thing as writing this. Next, I'm going to draw the valence electrons around fluorine. So fluorine is in group 17, so it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Okay. Actually, we're going to make those a different color just so that we can see some differences in those elements. Okay. Okay. Also, I'm going to have the single electron in the fluorine facing the boron, excuse me. So again, this is still saying the same thing as we had written previously. Same thing with this, okay? And now I'm going to rearrange my elements so that each element is surrounded by 8 valence electrons, with boron, of course, being one of our exceptions. So if I take the fluorine and I do this, we can see that the fluorine is now surrounded by 8 valence electrons, okay? The boron, however, is not, and it is one of those exceptions. It can only be surrounded by 6 valence electrons. So it's almost like putting a puzzle together. This fluorine I'm going to move here. Now this fluorine is surrounded by 8 valence electrons, which is what we want. Boron, however, it still needs to be surrounded by 1 more electron, so it will be surrounded by 6. And this fluorine right here, if we move it over, is now surrounded by 8 valence electrons. And our boron is now surrounded by 6 valence electrons. Again, it's one of the exceptions to the octet rule. So these electrons being shared will be a single bond, so will these electrons, and so will these electrons. So for my final Lewis dot structure, we have a single bond between the boron and the fluorine here, a single bond between the boron and the fluorine here, and here. Again, each of these bonds is representing 2 electrons that are being shared, okay? However, these electrons surrounding the fluorine These are what we call the lone pairs. And they do not participate in bonding, so they're not going to form a bond. And so this would be my final answer for my Lewis dot structure.